My name is Jakub Rosinski. I'm a principal solutions architect with Amazon Web Services, specializing in media entertainment, gaming, and sports. Today, I'd like to guide you through our AI-assisted promo assembly with creative control demo. Thank you for joining. Media companies and rights holders struggle to scale promotional content creation, highlights, trailers, and reels across multiple platforms, formats, and languages while maintaining creative quality. Traditional workflows require significant manual effort to select scenes, adapt formats, and coordinate localization, making it difficult to scale without compromising editorial standards. This demonstration showcases a content composition platform that amplifies human creativity rather than replacing it. Powered by Amazon Bedrock with Amazon Nova Foundation models, Amazon Elemental Inference, and AWS partner solutions from Moments Lab, 12 Labs, and DeepDub, the system uses natural language prompts and AI agents to orchestrate scene selection, localized narration, and context-aware reframing. Human oversight is maintained at 3 decision points: workstream configuration, scene review, and final output approval. The result: faster campaign creation, scalable multi-platform delivery, and creative teams focused on direction rather than repetitive production tasks. So let me show you how this looks in practice. Let me walk you through the user experience of this demo, focusing on 2 key personas, the producer and the editor. In the dashboard, you will see 2 workstreams configured for incoming content, one for the fictional series Reacher and another for basketball sports content. When you click on the Reacher workstream, you can view the output products currently in production and their status. Here we see a trailer that's requesting human-in-the-loop review, specifically a pending clip review task. Selecting this task takes us to the clip player window, where you will see all scenes pre-selected by the AI models for inclusion in the trailer. Each scene is highlighted with its description and position on the timeline. You can modify scene boundaries directly on the timeline, reorder scenes, edit the AI-generated commentary, or remove scenes entirely. Once you approve the selection, the workflow automatically continues, creating output derivates and performing dubbing. Output products like these are originally configured by the producer through the front-end interface. You can select a prompt template for scene selection, specify the AI-based indexer to use, and define target platforms. Additionally, you can configure reframing options and AI-driven commentary dubbing settings. These configuration options give producers fine-grained control over the automated content generation pipeline. The prompt template guides the AI in identifying key moments. The indexer selection allows you to choose between different AI models optimized for specific content types. The reframing capabilities use intelligent cropping to maintain focus on the action, automatically adjusting for vertical, square, or widescreen formats. Meanwhile, the AI-driven commentary dubbing can generate natural-sounding narration in multiple languages. Content sources are equally straightforward to configure through the web UI. You can either select an S3 source for file-based processing or integrate a live stream using Time Addressable Media Store, or TAMS for short. Let's circle back to those output products we looked at earlier. The process is now complete. You can see the full scene lineup used in the trailer plus all the final renditions. Here is a 9x16 portrait version, for instance, optimized for mobile platforms. As the producer, this is my final checkpoint. Review the outputs and approve them for distribution. Once I give the green light, they are ready to go live. So let me guide you through the flow and the architecture of this demo. A producer creates a new workstream through the web UI, specifying what content they want, what commentary they need, and which graphic package to use. The UI runs on Amazon S3 with Cognito authentication and DynamoDB database. Our live production workflow streams camera feeds and live events to Time Addressable Media Storage, or TAMS, which records video segments we can extract via API. When specific events happen, like a goal in a soccer game, the live event data in DynamoDB automatically triggers scene extraction from TAMS. For non-live content, our Edit in the Cloud solution lets users push master files directly to S3. Once videos are uploaded, Step Functions kicks off a workflow that reads the workstream configuration and dynamically adjusts the processing steps through Lambda functions. Lambda then leverages 12 Labs on Bedrock or Moments Lab to analyze the content and generate scenes. Amazon Nova Pro optimizes those scenes descriptions and creates the commentary text. An editor reviews everything: scene boundaries, ordering, descriptions before we move forward. Elemental Media Convert with elemental inference extracts and joins the scenes, reframing them to different aspect ratios like 1:1 or 9:16. Our partner solutions from DeepDub and ODub then vocalize the descriptions in multiple languages. The producer reviews the final reels and either approves them or sends them back for adjustment. Once approved, they move to distribution. And that wraps things up. Thanks so much for taking the time to watch this demo walkthrough.